Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to learn how to solve linear inequalities for mathematics grade 10. Please note that this is a follow-up video for how to solve linear equations. By now, you should be comfortable with solving all types of linear equations. If you're not, please go watch the video. I've already done that video on how to solve linear equations for mathematics grade 10. I'm also going to post the link on the description box so you can just follow that video from there. On that note, please don't forget to click the subscribe button so you don't miss out on new videos we upload in the future. And if you have a question or would like to make a video request, please comment down below with the topic and grade you'd like me to cover, or alternatively send all that information to the contact details provided in the description box. Also, don't forget to like and share this video with all friends on all social media platforms. Now back to the video. In detail, we're going to look at the definition of a linear inequality and how that is related to a linear equation. Remember, I said that you need to understand how to solve equations in order to solve inequalities. So that basic knowledge is very key and important. Next, we're going to look at different notations that we use to represent the solutions that we find after solving a linear inequality. And in this grade, we're going to focus on two in particular, and that is the interval notation and the number line notation, and you'll see exactly how that all works out. Number 3, lastly, we're going to look at examples that will help illustrate all the knowledge that you have gained on this video by the end. We have a lot to cover, so let's start. First, with the description. Basically, a linear inequality is almost like an equation, but not quite. And the difference between the two is that instead of an equal sign in the middle between the two sides, you have an either greater than or equal to, less than or equal to, less than, or greater than, making that no longer an equation but an inequality. Now let's look at the different types of notations that we're going to use. First, let's look at the interval notation. The interval notation, basically, if you have a round bracket, it means that whatever number is close to the round bracket is not included in the solutions valid for that inequality after solving it. But if you have a square bracket, that number is also included. Now I'm going to make an example. For example, if you have 4 separated by a semicolon from 12, and you've got round brackets covering them, that means that both 4 and 12 are not included in the solutions. However, everything in between the two, between 4 and 12, is included, meaning that this is how you interpret it. The interval includes all real numbers greater than but not equal to 4, and less than but not equal to 12. If you have a square bracket, like I've already mentioned, that number is included. For example, you have a square bracket in front of 1 and a round bracket after 13, separated by a semicolon. That means your 1 is also included in the valid solutions for that inequality, but 13 is not. Everything in between the two is also included, and this is how you interpret that. The interval includes all real numbers greater than or equal to 1 and less than but not equal to 13. That's how you interpret it. Now notice also that your infinities, both the negative and positive infinity, always have round brackets, because you can never pinpoint an infinity number. It's just never ending. You can never put a pin on it. So you put round brackets to show that you can never have a definite answer there. So whenever you have an infinity, you will always have a round bracket, never a square bracket. Now in this case, if you've got a negative infinity on the left hand side with a round bracket, obviously separated from a negative 1 with a round bracket also on the right hand side, that means this interval includes all real numbers less than negative 1. Less than negative 1, because you can only go to the left of the number line from there. So it's all real numbers less than but not equal to negative 1. Now let's look at the number line notation. We're going to take all those interval notation numbers and present them on the number line so that you can see how that works out on a number line situation. Now if you've got the first one where we've got round brackets 4 and 12 in the middle, that means this solution lies between 4 and 12, but 12 and 4 are not included, and that's why you've got hollow circles on top of 4 and 12 and a line between them, a solid line connecting the two. That's how you represent that on a number line. The next one you represent on a number line that goes, your solution is less than -1, but not including -1. So what you do is you put a hollow circle on top of -1 and a solid arrow pointing to the left, because that's where negative infinity hits. If the situation was with, for example, you had -1 and then a positive infinity on the right hand side, or with round brackets, what that means would be that all your numbers, your solutions, are greater than -1, but not including -1. So you will have a hollow circle here, over here. You would have a hollow circle over here. Let me show you. You would have a hollow circle with your arrow pointing to the right, because it's approaching positive infinity. That's how you represent positive infinity. Now for 1 and 13 with 1 included, you have a solid dot on top of 1 and a hollow dot on top of 13, and you connect the two. So your solution is between 1 and 13, including 1 but not 13. And that's how you show that it is included, by representing it with a solid dot. For this one, your number, basically the valid answers include -1, -1/2, -1/2, but they go all the way to negative infinity. So you'll have a solid dot on top of -1/2 and with an arrow pointing towards the left hand side. And that's, in a nutshell, how you represent your solutions on a number line. Now let's look at some examples that will help illustrate how we work with inequalities. Now notice something. Inequalities have this one thing that differentiates them from equations. Whenever you multiply or divide by a negative number, your inequality changes where it looks, and you'll see exactly how that happens with an expression in this example. So for R, that's example 1, 6 minus R is greater than 2. Represent the answer on a number line and interval notation. So we're going to do both notations. Okay, let's start by solving the inequality. So what you do is, step number 1, you solve this like you would any equation. Forget for now that it's an inequality and just solve it like you would any equation. You've got 6 minus R. So what you do is to take everything that is not R, your variable, to the right hand side. That's step number 1. So you go -R is greater than 2 minus 6. Notice -6 because you had it a 6 on the left hand side. So when you take it to the right hand side, it crosses that border. So it changes the sign. Therefore now -R is greater than 2 minus 6 is -4. All right. Now you have a situation where you have a -R and you're looking for a positive R. So what you do is you divide both sides by -1. So you divide that by -1 and you divide -4 by -1. But notice something here. Now that you are dividing by a negative number, your inequality changes where it looks. So instead of going greater than, it will have to be less than now. Very important, don't miss that detail. Let's change back to the color. All right, so therefore, positive R is less than +4. Notice how dividing by a negative number has changed the whole interpretation of the same inequality we started with as a greater than. Very important. So now your R is all numbers less than +4. So how do we represent that on interval notation? You've got your 4, right, on the right hand side with a round bracket because it's less than, right? And you've got your negative infinity because they say the numbers must be less than 4. Anything less than 4 is to the left of the number line, to the left of 4, and that goes all the way to negative infinity. And that's how you represent that in interval notation. How do we represent the same thing on a number line? What you do is you must have a hollow dot on top of 4, because our 4 is the crux number. So we have that hollow dot on top of 4, and then an arrow pointing to the left because it goes towards negative infinity. And that is how you interpret that. That's how you represent that on a number line, and that's how you represent the same in interval notation. Your crux number is 4, and it goes all the way to negative infinity. Next question. Solve for Q. 4Q plus 3 is less than 2 in brackets, Q plus 3. Represent the answer on a number line and in interval notation. Notice that even though you're dealing with an inequality here, you must always keep the same methods you use to solving equations present. If you've got to expand, you need to expand. If you need dealing with the fractional equations or inequality, you must also treat it like you would a fractional equation. Very important. So all the knowledge you have collected on how to solve linear equations is very important. Now, so what you do is 4Q plus 3 is less than, now you expand, that becomes 2Q plus 6. Step number 2, you take all the Q's to the left hand side, never forgetting to change the sign, and all the numbers to the right hand side. Also keep the signs with the rules. 4Q minus 2Q, that is 2Q, is less than 6 minus 3, that is 3. Now therefore, divide this all throughout by 2 to get Q on its own, 3 over 2. Therefore, the 2's cancel out. The 2's cancel out. And you're left on the left hand side with Q is less than 3 over 2. 3 over 2 is equals to 1.5. Now, to represent that on interval notation, Q is less than 1.5. So that means we have 1.5 as a crux number. Q is less than, so it's to the left hand side of the number line, so we have a negative infinity on the left hand side. How do we represent that on a number line? Easy peasy, we put a hollow dot on top of the crux number, which is 1.5. There's our hollow dot on top of 1.5, and the number line faces the left hand side. It goes towards the left because that's where negative infinity goes. And that's how you represent that on a number line. That's how you represent it on interval notation. Next question. Solve for x. 5 less than or equals to x plus 3 less than 8. Very important. Now you've got your x in the middle of two inequalities on either side. You solve it the same way you would any other equation, but let me show you exactly how you do that. So you go, therefore, well, we've got our x plus 3 in the middle. So what you do is, what would you do in a normal situation when you had an equation like this? Forget the right hand side. You will take the 3 to the left hand side, and whenever you take it to the left hand side, it changes a sign because it's crossing the border. So what you do is you take the 3 or the number outside of the middle part of the inequality. And when you do that, don't forget that it changes the sign. So we have, all right, everything stays the same. All right, so we've got x in the middle now because we've taken 3 out. So on the left-hand side, we end up with 5 minus 3. You take it out to the left-hand side, it becomes minus 3. But you must also take it out to the right-hand side. And that's what you get on the right-hand side. Very important. When you take out the number inside, in the middle part, you must make sure that it is distributed to both the left-hand side and the right-hand side. Very important. And keep the sign rules applicable all throughout. And let's go back to my lovely color. Alright, therefore, 5 minus 3 equals to 2. Less than, sorry, I made a mistake here. This should be less than, not less than or equals to. That is 2 is less than or equals to x less than 8 minus 3 is equal to 5. Alright, now how do we represent this on interval notation? You've got a solid, you've got a square bracket on the left hand side because of the less than or equal to, and you've got a round bracket on the right hand side because of the less than. There you go. And then what are the parameters? You've got 2 on the left hand side and you've got 5 on the right hand side, and that's how you represent that on interval notation. Now, how do we represent this on a number line? Easy peasy. The one with less than or equals to has a solid dot, and the other one that does not have an equal to sign, but just less than, has a hollow dot. So you go hollow dot on 5 and solid dot on 2. Solid dot on 2, and you join the 2. And that's how you represent that. So your x is between 2 and including 2 and 5, but not including 5. And that's how you represent that on the number line. This is how you represent it on interval notation. Next question. Now in this question, you have the question that says, look at the number line and write down the inequality it represents. Now we're representing the number line into an inequality. Very important. You should be able to do both sides. You should be able to go back and forth without any problems. Now on this number line, we've got a hollow dot on top of -1, meaning that -1 is not included, and an arrow to the left hand side, meaning that your number or whatever valid answer you have goes all the way to -infinity. So that's number 1. So you go A. All right. Your x is less than -1. And on the right hand side, we've got another piece, and we've got a solid dot on top of 6 with an arrow pointing right, meaning that it goes towards positive infinity. The solid dot on top of 6 means that 6 is also included. So our answer says, and x is greater than or equal to 6. Also, your x is an element of real numbers, very important. Number B. We have a solid line in between 3 and 6 with hollow circles, hollow dots. That means 3 and 6 are not included, but everything in between them is included. So we've got your x is in between 6 and 3, and they are not included. So you do not have the equal sign part of that inequality. Your x is an element of real numbers, very important. Number C. You've got a hollow dot on top of 3 and another one on top of 6, but a solid line everywhere else. This means that your x is an element of real numbers, but not including 3 and 6. So meaning that x is not equal to 3 and x is not equal to 6. X is not equal to 3. X is not equal to 3. And x is not equal to 6. But x is an element of real numbers because everything else, including your fractions and everything, is included. Number D. Here you've got a hollow dot on top of negative 10, meaning that negative 10 is not included, but you've got a solid line going all the way to the right hand side towards positive infinity. That means that whatever your answer is, it's greater than negative 10 and not including negative 10. So your number is greater than negative 10 but not including it. And then your x is an element of real numbers. Very important there. And that's how you represent all these number lines into an inequality. That's how you write the number line notation into an inequality. Now, example 5, solve for x and represent the answer on a number line and in interval notation. All right, let's go. On this one, we have a fractional inequality. Like we would deal with a fractional equation, linear equation, the first thing you do is you find the lowest common denominator. Very important. What is the LCD? The LCD between 2, 3, and 6 is simply 6. And what you do now is you multiply each of the fractions by that LCD. So that's 1 over 2x multiplied by 6. The 6, 2 goes into 2 once and into 6 3 times. So you multiply all that by 3. So that becomes, therefore, 3x plus 1 over 3 in bracket x minus 1 multiplied by 6. 3 goes into 3 once and into 6 twice. So you multiply that by 2. That becomes 2 multiplied by x minus 1. And now on the right hand side of the inequality, greater than or equal to 5 over 6 x multiplied by 6. The 6 is cancelled and you're left with 5x. Minus 1 over 3 multiplied by 6. 6 goes into 6 once. 3 goes into 6 twice and into 3 once. So that leaves us with negative 2 on the right hand side. Now, therefore, like you would in an equation, you now expand whatever needs to be expanded. So 3x plus 2x minus 2 is greater than or equals to 5x minus 2. And now you take all x's to the left hand side and all numbers to the right hand side. So that's minus 5x greater than or equals to minus 2 plus 2 from the left hand side. There. And now you add like terms. 3x plus 2x, that's 5x, minus 5x, so that is 0x. So that's 5x minus 5x is greater than or equal to negative 2 plus 2. 5x minus 5x, that's 0x, is greater than or equal to negative 2 plus 2 is the same as 2 minus 2, that is 0. Now, when you have a situation like this, you've got 0 on the left-hand side on your axis and 0 on the right-hand side on your numbers. That means that your x is an element of real numbers. Any real number will solve this equation. It's valid for all the equations. So, therefore, your x is an element of all real numbers. Any real number will satisfy that equation. How do we represent that on interval notation? Okay, in interval notation, basically you have infinities on both the right hand side and the left hand side. On the right hand side, you will have positive infinity, and on the left hand side, you will have negative infinity. In other words, your x is between positive and negative infinity. Every number on the number line, the real number line. How do you represent that in a number line? This is how you do that. You get a line pointing both ways in that number line. This number line is my student. And that's how you represent that on in interval notation and the number line. Next question. Solve for x and represent that in the number line, on a number line and in interval notation. Okay, let's do that. So we go, therefore, okay. Now notice something also, we've got this situation where you have an algebraic expression in the middle with inequalities on either side. So notice something. This is a fractional inequality. So step number one, find your lowest common denominator. In this case, our lowest common denominator is -3. There, it is -3. So what you do is you multiply all sides, including the middle, with that -3. But notice something. You are multiplying by a negative number. And what happens when we multiply by a negative number in an inequality? The inequality changes the direction where it looks. So instead of less than on both sides, it will now become greater than, because we are multiplying by a negative number. So this negative number cancels over here. It cancels, including the negative signs, they also cancel each other, and you are left with, let's go back to the color. And you are left with, therefore, on the left hand side, -2 times -3, that is +6, is greater than x minus 1 is greater than, because the -3 cancel out, -21. All right. Now, what you can do next is now you switch these around. You take everything on the right-hand side to the left-hand side, take everything on the left-hand side to the right-hand side, and you switch the inequality sign. So the -21 is now going to be on the left-hand side with your x minus 1, still on the right-hand side, fine, and the 6. So, but notice that when you do the swinging and changing around, you also change the inequalities back. Let's go back. So now that becomes, now we go ahead taking out the -1 out of the middle, so it becomes +1 on the left hand side, plus 1, x in the middle, 6 plus 1 on the right hand side. -21 plus 1, that's -20. 6 plus 1, that is 7. So you have an inequality that is between 7 and -20, and not including them. How do you represent that on interval notation? That becomes, you've got your 7 and you've got your -20 with a semicolon in between there, and round brackets on either side, because none of them are included according to the inequality. None of them are included. How do you represent that on a number line? First, none of these are included, so you put hollow circles on top of each one of them. So we've got a hollow circle on top of 7, or we have another hollow circle on top of -20, and we join them together. Easy peasy. Just join them together. Alright, there you go. And that's how you represent that on a number line. Next question. Similar inequality where you've got inequalities on both sides and an algebraic expression in the middle. You solve it the way you would a similar situation. So you go therefore. Now we've got 3. We've got 16 on the other side. Now you take out the 4 outside of this middle inequality, and it becomes positive 4. No, it becomes negative 4, sorry, on both sides, and you're left with negative x. 3 minus 4 is equals to negative 1. 16 minus 4 is equals to 12. Now you've got a negative x in the middle, and you're supposed to divide that by a negative number to make it positive. So what you do is you divide all of the sides by negative 1. But remember, whenever you divide or multiply by a negative number, you switch your inequalities around. So the inequality now switches. It becomes greater than or equals to instead of less than or equals to. And therefore you have, let's go back to our color. And therefore you have, therefore 1 is greater than or equals to x, greater than or equal to negative 12. And now you switch them around again. Therefore, negative 12 on the left-hand side, x in the middle, and the other one is 1. 1 on the right-hand side. And the inequalities also switch. Now, instead of greater than or equal to, they become less than or equal to. And that's how you solve that. And now how do we represent that on interval notation? Let's get back to the color. On interval notation, this is how you represent that. You've got square brackets on both sides with a semicolon in the middle, and then you've got 1 on the right-hand side, negative 12 on the left-hand side. Now what happens is that on the number line, that becomes an easy representation. You've got your solid dots on top of 1 and negative 12, so that you've got your solid dot on top of 1. Let's change that into a solid dot, and another solid dot on top of negative 12. So you've got another solid dot on top of negative 12. And then you join the two. And that is how you represent them on a number line and on interval notation. Next question. Solve the unknown variable and show your answer on a number line. Notice something here. We not only have an inequality like we did with the others, but they're specific about what type of a real number the solution must be represented in. In this case, it's B must be an element of integers. Now we know integers are whole numbers including negative numbers and 0 in the middle with positive numbers to the right, all going to negative infinity all the way to positive infinity. So we keep that in mind when we solve questions like this. So we solve as we would any other equation. So we go, take everything that has got B to the left hand side, and take everything that has numbers to the right hand side. So the negative 3 becomes part. And therefore, 6 minus b, that is 5b, is greater than 2 plus 3 is equals to 5. Now divide both sides by 5 to get rid of the 5 on the left hand side, so we have b on its own. So what you do on the left hand side, the 5's cancel, give you 1. Now therefore, b is greater than 1. Now how do we represent that on a number line? Notice something also. Like I said, your b must be an element of integers. It must be an integer. Meaning what? Meaning that it must just be whole numbers that are bigger than 1. That means 1 is not included. So how do we represent that on a number line? That means we put solid dots on any number that is a whole number, an integer, greater than 1. So that's what we will have here. Another one here. Okay, we will have another one on top of 4. And so on and so forth. So we have these solid dots all the way to infinity, but on numbers. So what we do to represent that is we draw an arrow pointing to the right to show that all these integers to the right of b equals to 1 are valid. Now, in other textbooks, they also show that 1 is not included by putting a whole dot there. It's not necessary. You can leave it out if you feel like it, because it's really not included. But you can show it is part of the inequality because it is actually at least mentioned, just not included but mentioned. So this is how b is greater than 1 and b is an element of integers is represented. Next question. Similar question, but now the variable a in this case must be an element of natural numbers. Now, if you're not sure what natural numbers are, these are counting numbers. Like I said, I've already done the video on the number system. So if you're not sure what that is, what the numbers are, who's who in the number zoo, go watch that video. I'm also going to add it to the description box of this video. So go watch that video so you understand the numbers that we're talking about and who they are in the number line and how we identify them. Now what you do is you solve this like you would any equation. So take your a's to the left hand side is less than, and your numbers to the right hand side. 3a minus 4a, that's negative a, is less than 6 plus 1 is equals to 7. Negative a. 6 plus 1 is equals to 7. Now divide both sides by negative 1 to get a positive a. But remember, whenever you divide by or multiply by a negative number, in an inequality, your inequality changes where it looks. So that becomes greater than instead of the less than you started with. Therefore, our a is greater than negative 7. And it must be an element of natural numbers. Natural numbers are counting numbers starting from 1. And they're whole numbers. So it's 1, 2, 3, 4, all the way to positive infinity, but only whole numbers. They don't include 0. So any natural number that is greater than negative 7 will have to start at 1 and not 0. So you put your solid dot on 1, 2, 2, 3, and so on and so forth, and to show that this goes all the way to infinity, positive infinity, you put a number line and an arrow going right. So in other textbooks, like with the last one, we can include 0, but with a whole dot showing that it is really not included, but you can use it as a reference. It's up to you. I personally wouldn't put it there because it's not a natural number, but that's okay. Next question, and the last one, is b over 3, b minus 3 over 2 plus 1. This is a fractional inequality. Now, if you've mastered your equations, your linear equations, the fractional ones will be an easy peasy one. Now, step number 1, when you're dealing with fractional equations or inequalities, you find the lowest common denominator. Always. The lowest common denominator between 2 and 4 is 4. So now you multiply each of the fractions by the lowest common denominator, which is 4 in this case. So b minus 3 over 2 multiplied by 4. 2 goes into 2 once and into 4 twice. So you multiply that by 2. Therefore, 2 in bracket b minus 3 plus 1 times 4 is 4. It's less than b over 4 multiplied by 4. The 4's cancel out. 4's cancel out and you're left with b minus 4 multiplied by 4, that is negative 16. So that gives you negative 16. Now you expand, so that becomes 2b minus 6 plus 4 is less than b minus 16. Now you take everything that is b to the left hand side and everything that is a number to the right hand side. Therefore, 2b minus b is less than negative 16 plus 6 because it was negative 6 on the left hand side, minus 4 because it was positive 4 on the left hand side. Therefore, 2b minus b, that is b, less than, b is less than, negative 16 minus 4, that is negative 20. That gives you negative 20. Negative 16 minus 4 is equals to negative 20. And negative 20 plus 6, that is equals to negative 14. So you're left with negative 14. If you're not sure how to do that, use a calculator, especially in an exam. Don't try to calculate all these integers in your head. You're most likely to make the serious mistake and get the wrong answer as a result. Now, the answer is b is less than negative 14. And we're dealing with all elements of real numbers, so that makes life so much easier. Real numbers include everything, including negative numbers with the fractions and everything, so all is included. It makes life easy. B is 14, negative 14 is not included though, so we'll put a hollow dot on top of that. B must be less than. So because it is less than, that means the arrow goes towards negative infinity. And that is how you represent that on a number line. Thank you for watching this video. We've come to the end of the video. I'll see you in the next one. Bye.